Hey, and I'm not swearing. Dam break. Okay, do you get it? All right, so here we go. Okay, this is a numerical simulation, not a real uh, experiment, a virtual experiment. But anyway, so you have a tank, and on one side, you can see the red is that's a separator, and the right hand side is filled with water to a certain height. We call it H. Okay, so what happens if you open the gate? If you break the dam, if you open the lock, the barrier. Okay, so what you want to do is this. You want to let the water go. What it will do, it will flow from right to left. But why is this? It is so because there is a pressure difference from right to left. What is pressure? Pressure is actually related to the weight of a substance above a certain point. And you can see that because there's fluid here on the right, there's actually a higher weight on the right side compared to the left side. And this actually produces a pressure gradient, which creates a flow. So what happens is now shown here. You create a flow, it collapses, and it creates a flow from right to left. And there's an obstacle here, and you can, it becomes reflected also at the other side of the tank. Okay, but I just show it again. See how it works. Can I just show it again? Yes. And this is what we call it, a dam break. And this is what you will be playing around with at Tonsley in the Tonsley. Okay, and the central question concerning a dam break is this initial wave that is created. Okay, it's a waterfront that moves. What's the speed of that? I'll show it again. What is the speed? Because if you know what the speed is, you can actually do some warnings. You can work out how long does it take to reach a certain position. All right, so now we come to the next problem then. What is speed? How do you calculate speed? Okay, here we go. So essentially what you do is, in order to calculate speed, you need distance and time. So here's a little example. Now define L as the distance between point A and point B in this little sketch. Here you can measure it. It's the distance. Okay? Distance in meters. So now you can define the time as the time, the T, capital T, as the time it takes to move from A to B. And speed can then be calculated from the ratio of distance divided by time, L over T. Okay, because the unit for time is seconds, the unit of speed is meters per second, and you can convert it to kilometers per hour if you want to, but we're using international units, meters and seconds. So now, velocity is something different. It's a little bit more. Velocity, unlike speed, velocity also has a direction. What does direction mean? You can, in this example, you can move from B to A or from A to B. One, if you define the x-axis as pointing to the right, okay, the speed, the velocity from B to A is positive, whereas the velocity from A to B is negative. That's the difference. Okay. All right, so now you know what speed is, you know how to calculate. Yay!